Imagine standing before a mirror unlike any ever created. Instead of reflecting your face, it reveals fragments of the universe's distant past. Every beam of light entering this mirror has traveled across unimaginable distances, carrying messages from a time long before Earth existed. What you see is not the present, but a record of ancient events preserved in light itself. This is, in many ways, the purpose of the James Webb Space Telescope. While it is often described as the most powerful space telescope ever built, Webb is much more than a scientific instrument. It is a machine designed to look backward through time. Because light takes time to travel, observing extremely distant objects allows astronomers to see them as they were billions of years ago. The farther Webb looks into space, the deeper it looks into history. For decades, scientists developed a picture of how the universe evolved after its birth. According to the current cosmological model, the universe began approximately 13.8 billion years ago in an event known as the Big Bang. In the first moments after this event, the universe was unimaginably hot and dense. Space expanded rapidly, temperatures dropped, and the first particles began to form. As the universe continued to cool, these particles combined to create atoms, primarily hydrogen and helium. These simple elements filled the young cosmos, spreading across vast regions of space. Yet despite the presence of matter, the universe remained dark. Astronomers call this period the cosmic dark ages. During this era, there were no stars, no galaxies, and no planets. Matter existed, but there were no sources of visible light. The universe was a quiet and mysterious place, filled with enormous clouds of gas slowly drifting through space. Over millions of years, gravity began to change everything. Tiny variations in density, almost imperceptible differences in the distribution of matter, gradually grew stronger. Regions containing slightly more matter exerted greater gravitational pull, attracting even more material. Slowly but relentlessly, gravity gathered gas into increasingly dense concentrations. Eventually, these dense regions collapsed under their own weight, igniting the first stars. Those first stars transformed the universe. They produced light, heat, and new elements through nuclear fusion. Around them, the first galaxies began to emerge. According to traditional models, this process should have been gradual. Early galaxies were expected to be small, chaotic, and relatively simple. Complex structures were thought to require billions of years to develop. The deeper astronomers looked into space, the simpler the universe was expected to appear. Then the James Webb Space Telescope began its observations. When Webb focused on regions of the sky previously studied by other telescopes, researchers anticipated finding primitive galaxies in their earliest stages of development. Instead, they encountered something surprising. Many distant galaxies appeared far more mature than expected. Some showed organized structures. Others displayed bright central regions surrounded by large populations of stars. A number of them appeared surprisingly massive despite existing during a period when the universe was still very young. These observations immediately captured the attention of astronomers worldwide. At first, some researchers questioned whether the distances had been calculated correctly. In astronomy, distance is often estimated through redshift, the stretching of light caused by the expansion of the universe. If redshift measurements were inaccurate, these galaxies might not be as ancient as they appeared. However, as additional observations accumulated, the evidence became increasingly difficult to dismiss. Many of these galaxies genuinely appeared to exist only a few 100 million years after the Big Bang. In cosmic terms, that is extraordinarily early. It was as if archaeologists expecting to find the foundations of a village instead discovered a fully functioning city. The discoveries did not stop there. One of the most powerful abilities of the James Webb Space Telescope is its capacity to analyze the light coming from distant objects. By breaking that light into its component wavelengths, scientists can determine which chemical elements are present. The results revealed another unexpected mystery. Several early galaxies appeared to contain significant amounts of heavier elements, including carbon, oxygen, and iron. These elements are not produced during the Big Bang itself. Instead, they are forged inside stars and distributed into space through powerful stellar explosions. The presence of these elements suggests that stars formed, evolved, and died far earlier than many models predicted. This possibility paints a picture of an early universe that was far more active than previously imagined. Instead of a slow and orderly progression, the young cosmos may have experienced intense periods of star formation. Massive stars could have lived short but dramatic lives, enriching their surroundings with heavy elements and accelerating the growth of galaxies. Another challenge emerged from observations of supermassive black holes. These extraordinary objects contain millions or even billions of times the mass of our Sun. Before Webb, scientists generally believed that black holes grew gradually over immense periods of time by consuming matter and merging with other black holes. Yet Webb has identified evidence suggesting that some supermassive black holes already existed when the universe was still remarkably young. Their existence raises difficult questions. How could such enormous objects have formed so quickly? Researchers are currently exploring several possibilities. Some theories suggest that exceptionally dense regions of matter in the early universe may have collapsed directly into large black holes, bypassing intermediate stages of growth. Other ideas involve physical processes that are not yet fully understood. At present, there is no universally accepted explanation. The mystery extends beyond black holes and chemistry. The shapes of some early galaxies have also sparked debate. Rather than appearing completely chaotic, many display surprisingly organized structures. Certain galaxies show evidence of rotation, while others possess forms that appear more developed than expected for their age. These findings have encouraged scientists to re-examine the role of dark matter. Dark matter remains one of the greatest mysteries in modern science. Although it cannot be seen directly, its gravitational influence affects the motion of galaxies and the large-scale structure of the universe. Scientists estimate that dark matter accounts for most of the universe's total matter content. Some researchers believe dark matter may have played a more significant role in organizing cosmic structures than previously thought. Instead of merely providing a gravitational framework, it may have helped accelerate the formation of galaxies during the universe's earliest stages. Perhaps one of Webb's most fascinating contributions involves the chemistry associated with life. The telescope has detected complex carbon-containing molecules in distant regions of space. These molecules are considered important ingredients in the chemical processes that can eventually lead to life. Their discovery does not prove that life existed in the early universe. However, it suggests that the fundamental building blocks required for biological chemistry may have been widespread long before planets like Earth formed. This realization carries profound implications. If the ingredients for life emerged early and frequently throughout the cosmos, then the conditions necessary for life may not be exceptionally rare. The universe may be far more chemically fertile than previously imagined. With every observation, the James Webb Space Telescope continues to expand humanity's understanding of the cosmos. Some discoveries confirm long-standing theories. Others challenge assumptions that have guided astronomy for decades. That is the nature of scientific exploration. Every answer uncovers new questions. Every discovery reveals deeper mysteries. Perhaps the most remarkable aspect of Webb's mission is the journey taken by the light it observes. Each photon collected by the telescope began its voyage billions of years ago. Many started traveling across space before our planet existed, before the formation of the solar system, and long before any living creature could wonder about the universe. After crossing unimaginable distances, those ancient signals finally arrive at our instruments, carrying information from the dawn of cosmic history. By capturing that light, humanity has gained access to one of the greatest stories ever told, the story of the universe itself. And as the James Webb Space Telescope continues its mission, one thing becomes increasingly clear. The deeper we look into the cosmos, the more we realize how much remains unknown. Somewhere within that ancient light, hidden among distant galaxies and forgotten epochs, new discoveries are waiting. They may refine our understanding of the universe, or completely transform it. The search has only begun.